Considering we are learning about climate change and its potential impacts on the planet, let's focus on Michigan. But before we do that, let's show how we make these projections. First off, we use climate models. These climate models can work in a number of ways, but a common method is to break the globe up into a grid and to calculate certain variables for each grid cell. If a model is proven accurate by comparing it with historical data to make sure the model is calibrated correctly, then it can be used to make projections out into the future. From there, we can tweak the model, perhaps adding changes to carbon dioxide concentrations over time to see what the reaction in the global climate system will be. If global carbon dioxide concentrations increase, the atmosphere will respond accordingly in the form of warmer temperatures and different precipitation patterns. Currently, the most powerful suite of models is the Coupled Model Intercomparison Project Phase 5, or CMIP-5 Ensemble. CMIP-5 was established by the Intergovernmental Panel on Climate Change in 2008 and has no less than 30 different models attempting to model potential changes to the Earth's global climate system out until 2100. What makes CMIP-5 special is the power behind these models and the amount of variables and different options one has to customize their models. These models include the much anticipated RCP scenarios, which model how the world will increase and potentially mitigate the addition of greenhouse gases into the atmosphere at an unprecedented scale. All data from all of the CMIP-5 model runs totals up to more than 6 petabytes of data, which if you were to have that much data in the form of a standard MP3, the song would be over 2,000 years long. Now, back to Michigan. Using CMIP-5 data and a mathematical method called statistical downscaling, people at NASA fitted the CMIP-5 data for the lower 48 states from a 100-kilometer grid down to a 400-meter grid. For you GIS fans out there, you know that this is an incredible jump in resolution improvement. Consequently, we can get climate model data all the way down to a city or county level. Here are the projections for Ingham County using the average of all models at the higher greenhouse emission scenario. I've chosen to show January because winters are expected to warm up more than summers in the Great Lakes region over time. The CMIP-5 models predict an average warm-up of 3.8 degrees Celsius by about 2050, which is huge because average temperatures for the month of January are currently at -1 degree Celsius or about 30 degrees Fahrenheit. But different models have different results. Look at this list. The 4 American models all see an increase between 2.5 and 4.5 degrees Celsius, and the British model sees an increase of more than 6 degrees. Each model is calculated slightly differently, thus all results are slightly different. But the fact remains unequivocally clear that every single model predicts a warmer and wetter Michigan for the next 100 years.